All right, so this week, for the next few days, we're going to be doing 8.3, A through C, polynomials, linear factors, and zeros. But before we get started, I want us to recall a couple things from factoring. So we're going to first start off with our basic rules for factoring. So how do you factor a trinomial when your A equals 1? So notice here A is a 1, right? And so when we are doing this, we start off by saying, if I just have a trinomial with x squared plus bx plus c, what does that look like? Or what do I do? Well, let's look at the example. We have x squared plus 5x plus 6. And to factor this, we're asking ourselves, what factors of 6, so what multiplies to give me 6, will add to give me 5. So with 6, my factors are 1 and 6, 2 and 3. Out of my two options, the one that would make this a true statement would be 2 and 3. Okay, so notice I used a positive 2 and a positive 3. Here, I have x squared minus bx plus c. So I want a positive product, but a negative sum. Well, the only way that you can get a positive product is either having two positive numbers or two negative numbers. So if I had 1 and 6, we know 1 and 6 doesn't work, but if we have negative 1 and negative 6, that doesn't work either. So then let's try negative 2 and negative 3. So negative 2 times negative 3 is going to give me positive 6. Negative 2 minus 3 is going to give me negative 5. So my numbers are x negative 2 and x equals negative 3. So we have x minus 2, x minus 2, x minus 3. Okay? What if I have a negative bx and a negative c? What does that look like? Well, if I need a negative product, there's only one way to get a negative product, a negative and a positive number. So what negative and positive number will sum to give me negative 5? So would it be negative 1 and positive 6? Would it be positive 1 and negative 6? Or would it be negative 2 and positive 3? Or positive 2 and negative 3? So these are my options. So negative 1 and 6 makes negative 6. Negative 1 plus 6 does not make negative 5. 1 and negative 6 makes negative 6. 1 minus 6 makes negative 5. So our winner is 1 and negative 6. So we have x minus 6 and x plus 1. Using this list for here, the reason why I would still use this list is because I have a positive sum. I'm looking for a negative product. So only way to get a negative product is that one of them has to be negative. So out of my options, what works for this one is negative 1 and 6. So it becomes x minus 1 and x plus 6. Okay, so hopefully this sounds like a refresher. Special products. So sometimes when you're factoring, these may come up, and our special products are just if and when I see the scenario of saying factor x squared minus y squared. Remember, this is a difference of two squares. We called it dots. Or if it has x squared plus 2xy plus y squared. Okay, this is a binomial squared. So, or if I have x squared minus 2x plus y squared, it's going to come out to be x minus y squared. So these are my binomial squares. Other one, if I have perfect cube factors, or how to factor perfect cubes. So this is the sum of two cubes. And they're all just patterns, and patterns are just rules that we follow, right? In math, and this is the difference. 2 cubes. All right, so just some more little factoring tidbit. And next we have factoring by grouping. Factoring by grouping and factoring the Xbox way come in handy when your A is greater than 1. Okay, so if your A is greater than 1, this is typically what happens. The examples I'm doing, my A is not greater than 1. But just to show you. So what happens first is that if you multiply your A times your C term. So I have 1 times 12 in this case is 12. So I'm looking for what factors multiply to give me 12, but add to give me 7. That's why we can do it shorthand. So what multiplies to give me 12, but adds to give me 7? Well, 7x decomposes to 4x and 3x. After I decompose, then I'm going to group them. I either can group them as they are, or I can rearrange and group accordingly. So I group. After I group, I'm then going to factor out the GCF of each group. The factor, remember, you're getting kicked out the house, but you're still part of the family. You just don't live in the house. Okay? Now I'm going to factor out the common binomial. So my common binomial that I'm factoring out is x plus 3. So I factor out x plus 3. Again, it got kicked out, wasn't disappeared. And all I'm left with is x plus 4. So that's how that works, okay? Now, with your Xbox way, you are still your A, if it's more than 1, you're asking yourself, you're going to multiply. So in the top of our X, it's our A times our C term. At the bottom of our X, it's our B term. So we ask ourselves, what two numbers multiply to give me A times C, but add to give me B? I get my two numbers. I end up with 2 and 4. These two numbers are going to go inside of a box. So you have your square. And the first box is your first term. And the last box is your last term. First term, last term. Okay? Your two middle boxes come from the X. Okay? The X tells you what your missing X is. Boom. Then once everything is filled in, all you're doing is finding the greatest common factor of each row and each column. So the GCF of this row is X. The GCF of this row is 4. The GCF of this column is X. The GCF of this column between 2x is 2. Okay? Now, if the outside box is negative, that means your GCF is negative. If this outside box is negative, that means your GCF is negative. So this has at negative 4x, and my GCF is negative 4. It does not, so let me erase that. Okay, your outside are your factors. So on the outside, I have x plus 2, binomial factor number 1, and I have x plus 4, binomial factor number 2, and there is my factor. All right, so hopefully this sounded familiar and not brand new.